Good day, ladies and gentlemen. It's Mr. Nambane again. I hope everything is well. We are busy with our series of videos for momentum and impulse. But before we get into the lesson of today, just a quick reminder. Please subscribe to our YouTube channel, which is Nambane Academy, and also like us on Facebook. It is also Nambane Academy Institute for Math and Science. So the first lesson we had was basically an overview of each concept in momentum. But now to enhance the concepts, obviously we need now to have a set of questions, maybe do multiple choice questions as to enhance the concepts and be able eventually to answer questions in an exam. So as a way to do that, or to achieve a rule of us being able to answer questions in an exam, I have compiled a set of multiple choice questions, of which I feel that if each and every one of us understand the multiple choice questions, it will be easy to do more of the calculations. So I'm going to start by maybe giving out a few hints when we work with MCQ, which is now multiple choice questions. So the hints that I'm going to share, it's just my approach of how maybe to get to the correct answers. You maybe have your way of doing it. There's no problem with that. So this is just me sharing how I, in most cases, approach my multiple choice questions. The first thing that I do is, in most cases, I will read the stem at least twice. So this will help me be able to read the question, identifying, of course, the keywords. And once the keywords are identified, then I will be able to know that I haven't missed anything in the stem or the statement of the question as to what is it that the examiner is giving me as an information. Then secondly, I need to identify two distractors. Remember, it is a multiple choice question. So if it is a multiple choice question, I will be given 4 options to choose from. So if I am going to choose the correct answer between A, B, C, and D, so the only thing to eliminate questions is for me to look for distractors. So what are the distractors basically? Distractors can be any option that is not somehow related to the stem. Distractor can be any other information that it's irrelevant in terms of physics principles. And distractors can also be misconceptions of which we've been exposed to in the previous years. So for me to eliminate the distractors, it gives me now what? A 50-50% chance of getting the correct answer. Because once I have eliminated the 2, it says I am left with the 2. So to support now or be able to choose the correct answer, it means I must now apply physics principles. Principles, this will be to eliminate one incorrect answer. So applying physics principle, it's the question of, in the stem, I should be able to pick it up whether the question is on a different topic or which topic is being assessed. So once I know which topic is being assessed, then I can go back and remember or apply the physics principles to be able to eliminate one incorrect answer. So obviously, the only last step that we need to do or consider is now to write down the correct answer. Is to write down the correct answer. It's as simple as that. But supporting these 4 options or hints that I'm sharing, I always advise majority of people to say, kindly also know where to find the formulas related to the question. So I have taken this extract from the formula sheet. So these are equations that I feel and believe that when we work with momentum, impulse, then we should be able to know which formulas to apply, because now remember, the formulas are also part of physics principles that we need to apply. So once we are able to do that and know exactly which formulas to use, this will eliminate now using incorrect formulas for incorrect concepts. So kindly go back, also emphasize the issue that do I know where to find equations that are relevant in terms of the questions that are being asked. So this is just basically a hint of how to approach the multiple choice questions. Now that we have the hint, I have compiled also a set of questions where we are going to apply these hints if it does assist or works in. Okay, let me look for 1.1. Here is 1.1. So at 1.1, it says a constant net force acts on a moving object that is in a straight line. Which of the following physical quantity associated with the object will remain constant during the motion? Can I choose my distractors? Yes, I can. When I look at velocity, because I am given now that I have the net force, the velocity does not have any much of influence on the net force. So obviously velocity is going to be my distractor number 1. Can I identify my distractor number 2? Obviously velocity and speed goes hand in hand with the kinetic energy. So the kinetic energy in this case will also be a distractor. So I am left with 2 options. First option is momentum, and then the second option it's acceleration. So what is the relationship that I know between net force and momentum? So I know that F net is equals to changing P over changing T. And I also know that F net is equals to MA. Okay, let me remove this and then choose my pen again. It's F net is equals to MA. So these are the 2 physics principles that I need to consider. Why? Because the options I have, it's momentum and acceleration. I have already eliminated velocity and kinetic energy with the reasons stipulated above. So it says to me, but for me to have a constant net force, it means I must also have a constant change in momentum. This is very, very important. It must be change in momentum. So I do not have change in momentum as an option there. Then when I have net force that is constant, I am also going to be able to get a constant acceleration. So the hint here should be that when I look at the two, then definitely the correct answer here should be C, because the one there of momentum, which is wrong. Then the reason for that is, for me to have a relationship between F net, I should be talking about the change in momentum, not just momentum. So this is applying the hints. One, we start with eliminating the distractors. Two, we apply physics principles, and then physics principles will assist us in terms of getting the correct answer. Then let's move to 1.2. The linear momentum of an object is a vector quantity, scalar quantity, and then scalar quantity again. So we know from the first lesson, we did explain that momentum is a vector quantity. So can I eliminate my distractors? Yes, I can. Everything that says scalar quantity will not be applicable to me. So what else is left now? I can further read the question to say I am going to look at A and C, but now it's A says vector quantity with the same direction as the velocity of the object, vector quantity with a direction opposite to the velocity of the object. Now that's where the physics principle comes in. I know that it is a vector as the basic concept that I need to know. So which principle can I use for me to be able to identify which direction will my momentum take? Then I am going to use P is equals to mv. So when I use P is equals to mv, it says to me the only thing that will influence the direction of the momentum is this velocity here. So velocity and momentum should be in the same direction, should be in the same direction. That's 100%, because mass will not have any influence on the direction of momentum, but the direction of the velocity should be the same as the velocity of the momentum. So I'm looking for an answer where I have the same direction as the velocity of the object. So I will go back to my options, and then obviously this one says vector quantity with opposite direction, so automatically this one will not be correct. Then it means I will have my 2 marks at A. So it's easy. Eliminate the 2 distractors. After eliminating the 2 distractors, then apply physics principles. From the physics principles, it will be easy for us to choose the correct answer. And then at 1.3, a rubber of mass m traveling east at a velocity y hits a wall and bounces back towards west at a velocity of 1/2y. Then the diagram is given thereof. How does the ball kinetic energy after the collision compare to the kinetic energy before the collision? Can I choose my distractors? Let me definitely do that. I will know that the kinetic energy cannot be the same, because remember, we did say that energy will be lost once we have a collision. Then not enough information to tell, then this also cannot be an option for the correct answer. So I'm left with less than and more than. But knowing the concepts in detail, when I have a collision, that I'm going to have a loss in energy. So the correct answer there should be less than. But I'm going now to explain it in detail. Why should be the reason for that? I will start and say before I have EK, which is equals to half mv squared, but V is equals to Y. That is the information that is given. So this equation here will just be half mv my squared. So this is the kinetic energy before. Then after the collision with the wall, I have EK, which is equals to half mv squared, but now I am told that V is equals to half Y. So when I substitute into this equation, I will have half m 1 over 2y squared. Then when I manipulate it, I will still have half m, and then I will have 1 over 4y squared. So write it in a form that I have 1 over 4 into 1 over my squared. But I can easily see that this part here, it is the kinetic energy before. So I can say, okay, now it says E after, EK after is just equals to half or quarter, of EK before. So it basically says to me it is decreasing by a factor of 1 over 4. So EK after is smaller than the EK before, or less than the EK before. So I have just applied physics principles of now what? Energy in terms of me to choose the correct answer. So C will be an incorrect answer, and then less than will be the correct answer. And then at 1.4, for the two physical quantities, impulse and force, which one of the following is correct? We are looking at impulse and force. Then we know from our previous discussions that this one is a vector quantity, and then impulse, because of F net multiply by changing T and changing P, it means now it must also be a vector quantity. So I'm looking for vector. Can I eliminate my distractors? Of course I can. Impulse is a scalar, not true. Impulse is a scalar, also not true. So the only option I have here is impulse is a vector. I definitely know, but a force, it's not a scalar, but a force is a vector. So it means also this one should be incorrect. Then the only correct answer here will be impulse is a vector and a force is a vector. So the correct answer here is D. The correct answer is D. Let me make a mark. It's D. 2 marks for that. Then we can go further to 1.5. Then at 1.5, a body with a mass of 500 kg moves to the right at a velocity of 4 meters per second. So I am given the mass 500 grams. I am also given the velocity 4 meters per second. It collides perpendicularly with the wall and moves at 3 meters per second to the left. Which one of the following expressions represents the impulse on the body in Newton second? So let's have a scenario here where I have this body moving in this direction with 4 meters per second. It bounces off the wall in this direction with now what, 3 meters per second. The first thing to do is to have a choice of direction. So I'm choosing to the right as positive. So the first thing is, what could be the problem here? I know that my mass must be in kg. So if it is in kg, so I must now divide by 1,000. That is very, very important. So can I go into the question and remove or identify the distractors? Yes, I can. Everything that says 500 will not be correct for me because I need to convert the mass to kg. So I am going to use Fnet multiply by changing T is equals to changing P. Then Fnet multiply by changing T is equals to M V final minus V initial. Can I substitute? Yes, I can. I said my mass should be 500 divided by 1,000. Did I make a choice of direction? Yes, I did. So it means my 3 meters per second must be negative 3. And then my 4 meters per second must be minus 4. And then if I check here, I'm just going to have something that looks like 500 into minus 3 minus 4 over now 1,000. Can I see or check if I have such an option? Yes, I do, and that should be option number B. So option number B is the correct answer for that. So C will not be the correct answer for us. So what did we do? First thing, we eliminated the distractors because of, we know our mass must be in kg. Thereafter, we applied physics principle. Which principle did we apply? We applied now impulse momentum theorem. So from that, we are able to say, did we choose a direction? Yes, we did make a choice of direction. If you did not make that choice of a direction, most probably you're going to choose C. And C, it's incorrect because of the conversion of signs or signs that one decides to choose. So this is basically how I approach my multiple choice. I apply it regardless of which concepts or topic I'm based with or focusing on. So every time when I work with multiple choice questions, I always try to eliminate or identify my distractors. Immediately thereafter, apply the principles of physics. So if I'm able to apply the principles of physics, they assist me in terms of eliminating one incorrect answer, then definitely I am going to get the correct answer. So I hope we use this as a guideline for us to be in the right direction when we choose correct answers in multiple choice. I feel that a majority of us should get maximum marks because answers are already given. So it's just a matter of identifying the correct one. So I have a question here, which is question 2. And with question 2, it's just an issue that I want us to start building up to more complex questions. So this one focuses more on conservation of linear momentum. Why is that the reason? It is a reason because, and how can I tell if the examiner is going to assess me in terms of conservation of linear momentum. The first thing to do is, if I have two bodies or two objects that I'm working with. In this case, I have the rifle and then I have the bullet. So once I am able to identify that I have two bodies, definitely the questions that should follow should be questions based on the conservation of linear momentum. So let's go into it and try to write down all the important data that will assist us to get to the correct answer. So they are saying here, a hunting rifle of 3.6 kg fires a bullet with a mass of 8.4 grams. So that's where the problems comes. Already my mass is in grams, so I must convert it to kg. So how do I do that? Let me get my calculator. Then I will say I have 8.4 divided by 1,000 is equals to 8.4 multiplied by 10 to minus 3. So I'm going to have this here is 8.4 multiplied by 10 to minus 3 kg. So that is one thing that I need to look or work with, because remember, the SI unit for mass in this concept should be kg. So already I have picked up what needs to be changed from just reading the stem of the question. And thereafter they are telling me that it has now a speed of 914 meters per second. So I am going to read the questions, or maybe basically write down the data that is given. But from this, I have already analyzed it in detail. So the only thing that I need to work on is trying to answer the questions. So at 2.1, when we deal with the principle of conservation of momentum, we refer to an isolated system. What does the term isolated system mean? Remember, it is a definition, so it is either true or zero. No part marking, so you must give the correct definition. And remember, don't use definitions from anywhere else. Kindly use definitions from the CAPS document, definitions also from exam guideline, or terms and definitions that have been provided to you. So the correct definition will be: an isolated system is a system in which the net force or resultant force is equal to 0. It's 2 or 0. So 2 or 0, then you get your 2 marks. So we are looking for net force equals to 0. That is what we are looking for. Then at 2.2, calculate the velocity of the rifle at the instant the shot is fired. We need to write down some data before we can be able to apply this, because we are dealing now with a form of an explosion. Because what do I know before the shot has been fired? I know that before I have the mass of rifle together with the mass of the bullet. They are a unit because the bullet is inside the rifle. So I'm going to work with something like 3,6 plus 3,6 plus 8,4 multiplied by 10 to minus 3 kg. So that is what I am going to work with. That is the first thing. Do I know something about the velocity of the gun or the rifle with the velocity of the bullet before? Yes, I know that V of bullet plus V of R is equals to 0 meters per second. And then what happened after? After I know that I am having a bullet separately and I have the rifle also separately. So I'm going to say I have M of the bullet, which is just 8,4 multiplied by 10 to minus 3 kg. But I'm also told that V of the bullet after, it's something like 914 meters per second. Then what about the rifle thereof? M of the rifle is still the same, which is 3,6 kg. And then V of the rifle is what the examiner is trying to get from us. So which principle can I use? I can use conservation of linear momentum. So starting with the conservation of linear momentum, I'm going to say the sum of momentum before is equals to the sum of momentum after. But what happened before? Before I have M of R plus M of B as a unit. So they will have the same velocity, which is equals to M now of the bullet, V of the bullet, plus now M of the rifle, V of the rifle as well. Then this will be just substitution, 3,6 plus 8,4 multiplied by 10 to minus 3, which is equal multiplied by 0, which is just now 8,4 multiplied by 10 to minus 3 multiplied by 914 plus now 3,6 VR. Then when you do your mathematics and you solve for everything else, you'll get your VR as negative 2,113 meters per second. But remember, we are working with the velocity here. The question is clear to say calculate the velocity of the rifle the instant it has been shot. So velocity is a vector quantity. So if it's a vector quantity, it says to us we need to assign direction to it. So assigning direction to it, we'll be able to say VR is equals to 2,13 meters per second in the opposite direction. Opposite direction of the bullet. Opposite direction of the bullet. So the negative sign, it's only there to emphasize a choice of direction. So basically our final answer should have now what? The direction at which the rifle is moving towards. So we tend to make a mistake when we work with calculations. So I've learned throughout the years that there's a principle that we can use or an analogy that we can apply. So this analogy is an analogy of F sort. What F sort means is you'll have F for formula, that means choice of formula. So we made correct choice of formula, you get a 1 mark. You have now your substitution, then 1 mark will be given for substitution this side, and then 1 mark will be given for substitution that side. Then you have your answer together with the SI unit. So you have your answer 2,13 together with the SI unit. And then the last letter, which is D, it's the direction. So opposite direction to the bullet. So all this will give us now another mark. So kindly apply F sort in all the calculations that you are doing. It's the formula, substitution, answer, SI unit, and the direction if you are working with a vector quantity. There is no way that you can be given a mark without the correct direction. So in all the calculations that we do, kindly moving forward, know that we have an analogy that we use that is now F sort. So with F sort, it's your formula, substitution, answer, SI unit, and direction. And this is because of, even if you have the correct formula, let me change the color maybe here to yellow. Even if you have this correct formula, if you do not have the substitution, we don't allow or give a mark for the formula. Hence, it is important to say, let's have the formula and attempt to substitute. It's then that we can give this mark. So one thing also that I need to emphasize is this part here that will be highlighted in yellow. Let me get my highlighter and then make it somehow big. This part here highlighted in yellow, it's not a formula. It is situation dependent. So it is going to change over and over again as what? As we change or being exposed to different sets of questions. So it is not an equation, but it's just an expression of what the problem looks like, or the information that is given. So it is going to change in most cases. So my advice is this will only come from before and after what happened in the scenario that is given. So the best thing to do is always start with the principle. Which is the principle? The sum of the momentum before is equals to the sum of the momentum after. Then 2.3. 2.3, it says here, will the velocity of the rifle be greater than, less than, the same as if a heavier bullet is being fired? So to answer this one, I'm going to say at 2.3, I'm going to try and use the principle again. Change in the sum of momentum before is equals to the sum of momentum after. But we did say this will be 0 because it's an explosion. So I'm going to have M of the rifle, V of the rifle, plus now M of the bullet and V of the bullet. So what will happen? If I now decide to use anything bigger than 8,4, it will mean, if I am going to use anything bigger than 8,4, it will mean I am multiplying now this mass here with the same velocity, which is 914. But now this is bigger, so it means I am going to get a bigger answer here. Then transposing and solving for the mass here will still be 3,6 VR plus. So it means now solving and trying to find the correct answer for VR, it means VR will be higher because now I am now doing what? Multiplying here with a bigger mass, so I'm going to get a bigger value here. So this value here will be a bigger value or a greater value. So let's just say this one will be a bigger value. So it means VR also will also be big, because I will still be dividing with a 3.6. So the correct answer here should be greater than. So I will say its answer here, it's greater than, and then it's just 1 mark. It's just 1 mark, and then that will be the end of this particular question. That will be the end of this particular question. So it's questions that somehow look easy, but they are not easy because it's questions that allow us to have confidence when we move forward. So the idea is, let's not start with more complex things, we build towards the complex things. If the basics are done correctly, then it will allow us to understand more complex problems to follow. So this will be just part one of the problems that we're doing. We'll create another one where we now look into somehow challenging concepts. So I think this one is clear, and we exhausted it enough. So the second one we have here is 3.1. A 400-gram ball is moving horizontal towards a cricketer at a velocity of 40 meters per second. Then let's highlight what is important. We are given the mass, we are also given the velocity, but already we can see that our mass is in grams, so it means we need to convert this into kg. So when we convert this into kg, we will have something like 0.4 kg. Then it hits away by the cricketer in an opposite direction. It had to come from the net force of 400 newtons. The bat makes a contact time with the ball of 0.1 second, and then ignore all the vertical motions of the ball. So I will have my data for me to understand it fully. I will have my m, which is just 0.4 kg. I will have my f net, which is just 400 newton, and then I will have my v initial, which is just 40 meters per second. But what is the problem here now with this data of mine? The problem is I haven't assigned any direction in terms of the movement of the ball. So we normally use this direction to be positive. So it says to the right will be positive, and the force will also be positive in that direction. So it says to me, if my direction to the right is positive, then it means V initial must be negative. Then F net must be positive in the same direction. So this is me now trying to understand the information that is given. I'm also given t, which is equals to 0.1 second. So let's read the questions. I think we analyzed the information that is given. 3.1 says define the impulse. So defining an impulse, it's 3.1.1. It's a definition. I will forever emphasize it should be the definition as it appears in the exam guideline. So it is defined as the product of the resultant force resultant force acting on an object and the time resultant force acts on the object acts on the object acts on the object. So it's a definition. I will forever emphasize that in most cases it will be true or zero. So but we are looking for the keywords is the product of the resultant force and time the resultant force acts on an object. So this will be 2 marks as it is. So the idea here was we chose this question to emphasize that you have now to know the definitions. The first one we did in this question was isolated system. So this one is it's given impulse. So it means the other questions that are going to come will be different definitions, because the idea is to try and cover all the definitions that are possible in this section. So 3.12, it says calculate the magnitude of the final velocity of the cricket ball. So which principle or calculation should I use? I will write here that because I am only dealing with one object, which is the ball in this case, it means the equations that I'm going to use must allow me to have only one object. So when I look into the formula sheet that we spoke about, which is this one here, I have these equations here, and then I have that equation there. So it means why that? Because I can only accommodate one mass there. I can only accommodate one mass there. So let's go to the problem again and say I am going to have changing P, which is just M V final minus V initial. Then I'm going to have F net multiplied by changing T, which is just changing P. And then I'm going to have the last one, which is PMV. But when you check, these are equations that we can use when we have only one object to consider. One object to consider. So with us using these equations, definitely we need to have one object. So once we have one object, definitely these are the equations that will somehow assist us in terms of getting towards the correct answer. Then we can go ahead and do our calculation. We made our choice of direction. We have our data. Then we can easily say at 3.12, we are going to have F net multiply by changing T, which is equals to changing P. So it's F net multiply by changing T, which is equals to changing P. Then, but I know that this is just M V final minus V initial. So it's still your F net multiply by changing T. So is the direction of the force towards the right? Yes, it is. So it is going to be 400 multiplied by 0.1. The mass is given, it's 0.4. The mass is given is 0,4, 0,4, and then V final is what we are looking for. V initial is given. So V initial, it's in an opposite direction with our choice of direction, so it must be minus 40 meters per second. Then when we do the mathematics and solve this problem, we'll eventually find that VF is something like 60 meters per second. 60 meters per second. So still applying the principle of F sort. Remember, that's how the marks are also allocated. F sort, it's how we apply the marks. So the first mark will be for the formula. The second mark will be for the substitution. The third mark will be for the substitution. And the final answer will be the correct answer with the SI unit. So remember, it just said the magnitude of the final velocity. So we can still further assign it to say in an opposite direction with the ball, or in an opposite direction with the bat, depending on what is it that you want to say. But because the question only wanted us to calculate the magnitude, then it's fine for us to say 60 meters per second. So when you check question 2, the emphasis was working with two objects, which was the rifle and the gun, the bullet. And then when you check this question was only working with the ball. So it was the idea of combining conservation of linear momentum together with impulse. So with that, it becomes clear to understand that when I work with only one object, the chances are I am dealing with impulse calculation. So when I have two objects, then I am looking to work with conservation of linear momentum. Then it's important that when you have calculations to work on, kindly apply the F sort: choice of direction, formula, substitution, answer, SI unit together with the direction. So in most cases, you will be towards the correct answer. Even if you make a mistake, maybe out of the 4, we will be able to get the 3. So we need all the maximum marks that we can get. So I believe we did justice to these questions. We emphasized how to approach the multiple choice. We emphasized how to analyze the information given in the STEM to assist you to choose the correct formulas, do correct sign conversions. It's quite important for one to do that. So for me, I would like to say thank you very much for watching, and kindly don't forget to subscribe to our YouTube channel, which is Nambane Academy, as well as on Facebook page. Like us there, it's Nambane Academy, the Institute for Math and Science. So for you to subscribe, remember it's free. For you to like, it's also free, but it will assist you to not miss any new content that will be uploading. So from me to you, thank you very much and have a lovely day.